In thousands of ports around the world, a cinematic ballet unfolds every second of every day. Giant gantry cranes, moving with the precision of a Swiss watch, lift and stack enormous steel boxes. It's a system so vast and efficient, it feels almost alien, an invisible engine that powers our daily lives. From the phone in your hand to the food on your table, chances are a piece of it travels inside one of these containers, moving across the globe in this perfectly choreographed dance. But amidst this controlled chaos, there's a detail so obvious we often overlook it. Every single box is the same. The same dimensions, the same fittings, the same design. It doesn't matter if the port is in Shanghai, Rotterdam, or Los Angeles. This uniformity is the one constant in a complex global network. It's not just a design choice, it's a global agreement. But who made this decision? And why has the entire world followed it for over 60 years? To understand the genius of this simplicity, we have to imagine a world without this simple box. Forget the clean, mechanical ballet of today. The ports of the 1950s were a scene of organized chaos. Ships would arrive filled not with neat boxes, but with a messy jumble of loose cargo. Barrels of wine, bunches of bananas, crates of machinery, bags of coffee. Every single item was a unique challenge, a separate problem to be solved by hand. Each item had to be handled individually by longshoremen, a single crate or sack at a time. Imagine a chaotic puzzle with thousands of different pieces. Loading a single ship wasn't just a matter of hours, it could take an entire week. This immense amount of manual labor made the process incredibly slow and therefore extremely expensive. But the costs weren't just in time and money. With so much handling, goods were frequently damaged. And with so many people involved in a long, drawn-out process, theft was common. The entire system was a bottleneck, unpredictable and inefficient, adding a huge hidden cost to almost every imported product. The solution didn't come from a shipping magnate or a seasoned naval engineer. It came from an outsider, a man who was simply fed up with the inefficiency he was forced to witness. His name was Malcom McLean, and he was a trucker. In 1937, while delivering cotton bales to a port, he sat in his truck cab for days, watching the painstakingly slow process of cargo being moved by hand. For a man whose entire business was built on speed, this wasn't just a delay. It was a colossal, infuriating waste of time and money. It was in that moment of frustration that a simple, almost radical question formed in his mind. He wasn't thinking about improving the old system, he was thinking about replacing it entirely. Wouldn't it be easier, he thought, if my entire trailer could just be lifted and placed directly onto the ship? He saw that the truck and the ship shouldn't be two separate worlds. They needed to be part of one continuous, seamless journey. That initial vision of lifting an entire truck trailer was the spark, but the final invention was even more elegant and efficient. McLean quickly realized he didn't need the wheels or the heavy chassis on the ship. That was just dead weight and wasted space. The true breakthrough was to design a box that could be easily separated from the truck's frame. A box that was strong enough to be stacked high, secure enough to be locked, and engineered with a crucial innovation at its corners. These standardized corner castings were the key. They allowed the boxes not only to be lifted by a crane with perfect precision, but also to be locked securely to one another, creating stable, solid blocks. On April 26, 1956, the first of these reinforced steel boxes was loaded onto a converted oil tanker, the Ideal X, on its journey from New Jersey to Houston. The modern shipping container had officially been born. While the physical box was a brilliant piece of engineering, its true power lay in the revolutionary system it unlocked. This system has a name: intermodalism. At its core, it's a simple idea. The cargo stays inside the same sealed box for its entire journey, seamlessly transferring between different modes of transport. A container could leave a factory on the back of a truck, be loaded onto a train, transferred to a ship to cross an ocean, and then placed back onto another truck for final delivery, all without its contents ever being touched. This transformed the very nature of logistics. The port was no longer a chaotic place where one journey ended and another painstakingly began. It became a simple, high-speed transfer point. This was only possible because of McLean's strict insistence on standardization. Now, every crane, every truck chassis, and every rail car, anywhere in the world, could be designed to handle one uniform object. It was the birth of a truly universal physical language for global trade. And this is what that universal language looks like in action. A giant gantry crane locks on to the four-corner castings of a container stacked deep within a ship's hold. It hoists the 30-ton box into the air, glides along its rails, and with practiced ease, lowers it directly onto the waiting chassis or a rail car. The entire operation takes less than 2 minutes. No hands ever touch the cargo itself. No one needs to check the contents. This exact sequence is repeated millions of times a day in every major port on the planet. It's a simple, elegant, and endlessly repeatable process. The physical proof that a good idea, perfectly executed, can fundamentally change the world. The effect on global economics wasn't just an improvement, it was a seismic shift. Before McLean's invention, the accepted cost to load a ton of loose cargo onto a ship was $5.80. After containerization, that cost plummeted to just 16 cents a ton. That's a reduction of over 97%. This wasn't just because of lower labor costs. The real game changer was speed. A ship is only making money when it's moving at sea. By slashing port turnaround times from a week to a matter of hours, containerization allowed ships to make more trips per year, drastically increasing the efficiency of these multi-million-dollar assets. The old, crippling costs of loading, waiting, damage, and theft were virtually obliterated from the financial equation of international trade. That 97% cost reduction did more than just make shipping companies profitable. It effectively erased the tyranny of distance. Suddenly, the location of a factory was no longer tied to the location of its customers. A company could now manufacture a product wherever in the world it was most economical, where labor was cheaper or raw materials were more abundant, and ship the finished goods to markets on the other side of the planet for a tiny fraction of the product's final cost. This single change unleashed a wave of globalization unlike anything the world had ever seen. It completely rewrote the map of global manufacturing, fueling the economic rise of nations like Japan, South Korea, and later China. The reason your television, your furniture, and the clothes you're wearing can be designed in one country, assembled in another, and sold in yours at an affordable price all comes down to the simple, predictable economics of this standardized steel box.
So why are all shipping containers the same size? Because that uniformity is not just a feature, it's the entire system. It's a physical, universal language understood by every port, every ship, and every railway in the world. This global standard, officially managed by the International Organization for Standardization, or ISO, ensures that a box loaded in a small factory in Vietnam will fit perfectly onto a truck in Germany, a train in Brazil, and a ship in the middle of the Pacific Ocean. It's a language of trust and efficiency, guaranteeing that the complex puzzle of global trade always has pieces that fit together perfectly every single time.
It's easy to look at one of these containers and see nothing more than a simple, corrugated steel box. But in reality, it's a piece of the invisible architecture that holds our world together. It is the physical backbone of modernity, the simple solution to the colossal problem of distance. Every object it carries tells a story of global connection, a story made possible not by a flashy new technology, but by the quiet, world-changing genius of a standard size. If you found this story as fascinating as we did, show your support with a like and subscribe to Container Curious so you don't miss our next deep dive. And now, we want to hear from you. What's another mystery of the modern world you've always been curious about? Let us know in the comments below.